In this video, we are going to see about the trigonometric identity solving problem number 7. So sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta is equal to tan theta. So now we are going to first consider the left hand side. So now when we consider the left hand side, sin theta minus 2 sin cube theta, sorry, sin theta minus 2 sin cube theta that whole divided by 2 cos cube theta minus cos theta you are having, right? So now already I know that here as sin theta both the terms I'm there, I can take sin theta common outside. I'll be getting 1 minus 2 sin square theta. So both the side if I take here, if you multiply you must get back the numerator. So you can also cross check in that manner. The denominator cos theta is common. So I will be able to take the cos theta. Then you will be getting 2 cos square theta minus 1 you will be getting here. So now this sin square theta can be replaced by 1 minus cos square. As you know that sin square theta plus cos square theta is equal to 1 and sin square theta will become 1 minus cos square theta. So now this value only we are going to replace this here. 1 minus cos square theta will be replacing in the terms of sin square theta. So you will be getting sin theta inside the bracket 1 minus 2. Here you are supposed to place inside the brackets as we have two terms are available. So that whole divided by cos theta and 2 cos square theta minus 1. Then now this gets multiplied inside. So now you will be getting sin theta and 1 minus 2 plus 2 cos square theta that whole divided by cos theta into 2 cos square theta minus 1. So now 1 minus 2 you get as minus 1. So which is sin theta into minus 1 plus 2 cos square theta that whole divided by cos theta into 2 cos square theta minus 1. So you can now if you want you can write it in usual way 2 cos square theta minus 1 by cos theta into 2 cos square theta minus 1. So now this 2 cos square theta minus 1, 2 cos square theta minus 1 gets cancelled. Now left over sin theta by cos theta which is nothing but tan theta that is equal to the RHS, hence proved. So this is one of the method. If you want in the denominator, here you have cos square, right? There also you can substitute and do it in this problem. So let me teach you that way also how you can do it in the next slide. So first thing what you will do here, this is your another method I will write. Like with a slight variation, not with much variation. So now I'm going to take the left hand side. That is the left hand side you're having as sin theta minus 2 sin cube theta that whole divided by 2 cos cube theta minus cos theta. So I will be taking the sin theta common in the numerator 1 minus 2 sin square theta. In the denominator I will take the cos theta. You will be getting 2 cos square theta minus 1. So here what I am going to do is I am going to separate it as I know sin square theta plus cos square theta is equal to 1 I know here. So now I'm going to change the cos square theta. So cos square theta will become as 1 minus sin square theta you will be getting here. So now this value of that I'm going to substitute it here. This value I'm going to substitute that value here. So now sin theta into 1 minus 2 sin square theta that whole divided by cos theta into 2 into 1 minus sin square theta minus 1 you will be having inside a bracket. Now multiply inside to remove your bracket. So you will be getting here sin theta into 1 minus 2 sin square theta that whole divided by cos theta into 2 minus 2 sin square theta minus 1 you will be getting. So now here you will be having as sin theta into 1 minus 2 sin square theta that whole divided by cos theta into 2 minus 1. Here you have 2 minus 1, right, which will become as 1. So you get 1 minus 2 sine square theta. So now this both will get cancelled off. You will be getting sine theta by cos theta, which is tan theta, that is equal to your RHS. So both the methods are easy. One I have done with the numerator, other with the denominator substitution. It's very easy. If you have any such doubts, please comment me so that I can help you out in the next video. Bye students, take care.